Now let's have a nice time with some question here, and we want to take it from topic one. We'll be taking from one topic to another, and we can see we'll be learning. And as we are doing that, you also follow us. Now, we want to take question on measurement by unit. It said the dimension of magnetic field is dash. The dimension of magnetic field. The dimension of magnetic field. Of magnetic field. The symbol of magnetic field is. Now, first of all, the question you ask yourself, what is the formula for dimension of magnetic field or force, or the formula for magnetic field? First of all, remember that F equal to QVB. We have sine theta, or I don't want to, sine theta is dimensionless. So if I say B, this is a formula for magnetic force. We can also have it as F equal to BIL. I think anyone you want to use is better. I prefer we use the second one. You understand? So this one will not be what? B is equal to what? F over IL. This and this are the same thing. So anyone you decide to use is correct. So what is force? Force is what? ML square or MLT minus 2. Because force is mass times acceleration. Don't forget. So if mass is M, and the acceleration is LT minus 2. Remember the dimension of mass is M, length is L, time is what? T. Current is what? Electric current is what? A or I. Don't forget. The amount of substance is what? Small letter N. The luminous intensity is equal to J, something like this, then and so forth and so on. So in this case now, what we're going to do now is to place our all the dimension. What dimension for current is first? Dimension of current is, let's use A so that we can differentiate it. Then dimension for length is what? Is TL. So this is magnetic field times current times length equal to force. That means force on the current carrying conductor. This one will cancel this one. So our answer will now be MT minus 2 E raised to power minus 1. I believe you understand it. So that is now our answer. So I think the option here is option D. Now A says what? MT raised to power minus 1 E raised to power minus 2. No. B says M raised to power minus 1 L, then T E raised to power minus 2. C says M raised to power minus 1 L raised to power minus 2 T raised to power minus 1. Then T is the answer. NT raised to power minus 2 E raised to power minus 1. So if I will advise you, you can use this one too. The only thing is that the charge will now be equal to what? IT. Remember, if charge is equal to IT, what is the V? Velocity. Do you know that velocity times time is the same thing as length? Remember that velocity is the same thing as what? Displacement over time, or length over time. So if I cross multiply, so that means this particular ITV, which is this velocity, if you replace this one with L, you are getting what? BIL. So it's the same thing. Now the next one says the dimensional analysis. In dimensional analysis, what is the dimensional symbol of amount of substance? What is the dimensional symbol for amount of substance? The dimensional symbol for amount of substance is N. They wrote A, capital letter N. They can use small letter N, they can use capital letter N. Most of the times they even use big letter N for dimension. So I would prefer you use capital letter N for that one. Option A says capital letter N, B capital letter L, C capital letter M, and D T raised to power minus 1. The answer is N, capital letter N, which option A. L is what? Dimension for length. Then B is C says M. M is dimension for mass. Then T raised to power minus 1 is dimension for frequency. T raised to power 1 is dimension for frequency, not only frequency, also what? Angular what? Frequency. Not only that, it's also what? Dimension for what? Decay constant. Decay constant. Not only that, we can also say is what? Velocity gradient. Velocity gradient. Don't forget, velocity gradient is said to what? Velocity over length. Anytime they talk about gradient in physics, it has to do with over length. So listen and listen very well. So because this one now will now be what? That means L T minus 1. That is velocity now, which is no, velocity is what? Is displacement over what? Over time now. Abi? And displacement, anything that has to do with length, measuring devices or quantities like length, distance, height, width, breadth, altitude, displacement, extension, amplitude, they are all measuring in what? L. So in that case, will not be what? L over T, which is same as LT minus 1. So that's how if you divide it by length, what do you have? So you see that? So all of these are equivalent of T raised power minus 1 in terms of dimension. So similarly, you can have work, energy, torque, moment. All these one have the same dimension. And if you check very well, you are going to have it as force times distance, which is what is force? There is something you must understand. Force is what? ML what? T minus 2. Just know that one. In fact, force always mostly occurs in most of these dimensions. Then times distance. What do you have? ML what square T minus 2. This dimension for what? For work. Then or moment or torque or what? Moment or torque or energy. Although these two are vector, they have magnitude and direction. But these two are scalar. You cannot say moment is vector. You cannot say torque and moment are measured in joules. It's not possible because joules is a scalar quantity. It's not a vector quantity. So that work and energy are scalar. So although all of them have the same dimension, I believe that one is clear. So we don't forget this particular point that I want to give out. Don't forget that what dimension for momentum is MLT minus 1. These are common questions. This for momentum, take note of that. Dimension for what? Acceleration, LT minus 2. Acceleration, force, MLT minus 2, force. For surface tension, M what? T minus 2. The surface tension. Don't forget, surface tension is what? Force over length. Surface tension is force over length. Then another one again that you should note is after surface tension, also note gravitational constant. Very important, I beg. Very important. Gravitational constant is what? Is FR over what? MM. So it's more or less like ML T raised by minus 2 times for L over MM. So this one cancel this one. I would have what? M. This is force. This distance. This mass times mass. This is not length, meter. Mass and mass. Where do we get that formula from? If you remember from what? The law of gravitational field. This law, that is where we get that formula. This is R square, sorry. So this is L square. So this one will not be what? This one will cancel. We have L cube. This one is minus 1. If it goes up, it become minus 1. Then L cube, then T raised by minus 2. That will not be your answer for gravitational field. You can also work. You can practice it. Very important. Moment, power. Power. What is the dimension for power? Power is ml squared T minus 3. Power. Power is in as rate of heat. Like if they ask what is the dimension for rate of heat? Heat is in form of energy. So they might want to deceive you. Heat in form of energy. So anytime you talk about rate in physics, you talk about what? Divide by time. Don't forget we have many of them. We have the what? We have rate of what? Of volume. Rate of volume is volume over time, which is area times what? Velocity also. We have what? Rate of what? Momentum. Rate of momentum is same thing as force. They might want to deceive you. Why is the same thing? Momentum divided by time is rate now of anything. Momentum divided by time. What is velocity over time? Acceleration. So you have that, and so forth and so on. So that is just that. Then we can have rate of what? Of charge. Rate of charge is current. So rate of charge is a scalar quantity. It's not the rate of charge is a fundamental unit because it's referring to current. Don't forget, electrical current is a fundamental unit, a fundamental quantity. So if they now say rate of charge, they are referring to current. They are referring to current. So and so forth and so on. It is so you can have a lot of them. Rate of work, power, or rate of energy, power, and so forth and so on. But just note. Then if they talk about dimension or temperature gradient, I told you anything divided by anything gradient is temperature over what? Over length. This is temperature gradient or change in temperature over length, which is what? What dimension for temperature? It is either you use K or theta dimension, then over length, which is written as K L minus 1 or theta L minus 1. That is dimension for that. So please take note of that. Very important. Now we have answered. They say one of these following, one of these is a fundamental, One of these is fundamental. A, reactance. B, heat capacity. C, torque. And D, luminous intensity. So the answer to that question is what? Luminous intensity. Excellent. Because why? The shortcut for this one is what? Shortcut. Take note. We don't play with shortcut here. If you know shortcut is a sin, no need to take it. This is a shortcut. What is the shortcut of that one? This one means what? Mass. This is what? Electric what? Current. This is what? The time. This is what? Amount of substance. This is length and what? Luminous intensity. So luminous intensity. This one. Okay. Then T. T is time and temperature. Time and temperature. This T square. So time and temperature. So it's balanced. So anyone that is not here is not fundamental. Anyone that is here is fundamental. That means all these ones are fundamental. But anyone that is not, you can do elimination method. Like what we have in option A says what? Reactance, derive. B say heat capacity, derive. C say torque, derive. D say what? Luminous intensity, fundamental. Now, there are questions that are not here that you need to know. Basically, I want to read this chapter quickly. Number one is, what are the three things we use to measure length? To measure length, measurement of length, we use micrometer, screw gauge. Let me make this side. To measure length measuring devices, we have what? Micrometer, screw gauge. We have the what? The vernier caliper. We have what? The what? We can have meter rule. And lastly, we can have a rule, the tape rule. Now, in this case, take note of this vital point. Number one is that what is the least what? Or the maximum possible error. The maximum possible error we can have for this. Now, number one is that this one is measured in what? 0.001 centimeter. which is the same thing as what? 0.01 millimeter. Why this one is measured in what? 0.01 centimeter or 0.1 millimeter. This one is measured in what? 0.1 centimeter or 1 millimeter. Why this one is measured in 1 centimeter or 10 millimeter. So the least possible error for a year for this particular instrument, the least possible error, we have now least possible error, which is the reading accuracy that we want to have here. You know, something that you can have, the least possible error that you can have here is what? 0.01 millimeter. You will still maintain that. This one is what? 0.1 millimeter. But this one will not be what? 0.05 centimeter. If you divide this one by 2, what do you have to get it? 0.05. Why this one is what? 0.5 what? Centimeter. So these are the two, the table form for you to remember the length measuring what? Devices that you can talk about. Then the mass what? Instrument. The instrument used to measure mass. Don't forget, mass is the quantity of matter contained in a body. Mass is the quantity of matter contained in a body. So mass is constant from one planet to another. If you take your mass from here, from planet Earth to planet Moon, it will remain constant. So it is measured in kg. It is fundamental. Fundamental. It is constant. From where? From one planet or one place to another. It is what? Quantity of matter in a body. Matter in a body. Sometimes some textbooks will tell you it is a function of what? Matter. Or it is measured in terms of matter. Don't forget, matter is anything that has mass and occupies space. Now, let me put it like this. What if we say that it can be measured? It can be measured using what? Using what we call what? The principle of moment. Or let me say beam with an instrument. With an instrument. Instrument known as what? Known as being what? Balance. Being balance, or what do we call it now? Using what? The principle of what? Of moments. So if I have a what? A meter rule like this, I can measure the mass of this meter rule by applying principle of moments with measuring. Now, but listen, now the weight is different from all this. Weight can be what is derived, is measured in Newton, derived. Derived. It varies from what? One place to another, or one place to another. That is where I will now say, okay, if I have, this is a planet Earth. If this is a planet Earth, let's say this is the what? The equator of the Earth. And let's draw a longitudinal line through the Earth. Now we have the parallel of latitude along this position of the Earth. We have the parallel of latitude. The largest radius of the Earth is located at the equator of the Earth. Now we notice that what? That the weight is smaller at the equator but larger at the pole of the Earth. Listen on that. Why? Because the radius weight is inverse to what? Radius square. Don't forget, Now weight is defined as what? Gmm over what? R square from the gravitational field. Don't forget, weight is a gravitational force. Weight is the gravitational pull that what upon which the earth act on a body. Is the weight, is the gravitational pull of the earth on a body. That's weight for you. So that means that this is a gravitational force. So weight is a function of gravity. Is, as you can see now. So we can write weight apart from what you know it to be, which is this one is general what definition of weight. So weight is what? Is a function of what? Of gravity. Meaning that you can define the formula for weight in terms of gravity. Just like when you say F function of S equals to S squared. That means you can define this function, that means Y, in terms of X. So that is what is happening there. So now, I told you weight is smaller, is low at the equator. So at the equator, we have lower weight, but at the pole of the earth, weight is higher. So as you are going away from the equator to approach the pole of the earth, weight will get increased. Now, weight is what? Is a function of gravity. Weight is what? Proportional to gravity. That means increase in weight will lead to increase in gravity. That's why your weight on the earth is higher than weight in the moon. Your weight in the moon is smaller because the gravity of the moon is about 1.67 approximately meter per second square. Gravity of the moon. While the gravity of the earth is equal to what? 1.10 meter per second square or 9.8 meter per second square. Gravity of the earth. So if I give you a boy of 1 kilogram to go to the earth and the moon, let us experiment. You will discover that this boy will have what? 10 Newton on the earth and we have what? 1.67 Newton in the moon. So that means his weight is lesser on earth than in the moon. His weight is more on earth than in the moon. So that means why? Because weight is proportional to what? Gravity. That's why we say it's a gravitational influence. It's what? Weight is the gravitational pull on the body. So that is just that. So basically, we can explain other things you can do. It can be measured what? It can be measured with what? Measured with or using what? Using what? Spring what? Balance. Spring balance. Which principle does spring balance operate on? Hooke's law. Using what? Hooke's law. God bless you. Using what? Hooke's what? Law principle. Means you are getting ready for the exam. So that is just that. Thank you very much. Now, Hooke's law principle, that is what they operate. We have other things you can see. We can also use what? Apart from spring balance, we can use what? We can use which other instrument that we use? What is another instrument you can use apart from beam balance? Chemical balance, lever balance. You understand? You can use butcher balance, and so on and so on. So we are done with majorly what we need to know concerning chapter 1. If you want to know more, just go through my videos in detail to know more about chapter 1. You go through my videos, you see measurement and unit. Under measurement, you see there. So we are done with measurement and unit. We go to motion, or we go to vector analysis. Now we want to go to vectors and scalars, which is vectors and scalars. Question on vectors and scalars. But before we go to question on vectors and scalars, we should understand that vectors are those quantities that have magnitude and what? Direction. So vectors, they are what? Quantities with what? With magnitude and direction. So in that case now, what we are saying is that In fact, people that don't have direction, they are more in the street. You understand now? If you go through your street now, you see people that don't have direction. So they are more. So in physics also, we have more examples of scalars than vector. Okay, I think that one shock you a bit. Okay. It's the same thing. We're going to drop it. Don't forget. Scalars are quantities that they have magnitude but no direction. So we can have in a family where one will be conductor and one will be doctor. It's possible. Or there's at least there's a doctor in the two of them. So this one what? Scalar is what? Are quantities. Please change it to plural. Are quantities with what? Magnitude only. E.g., that is where they want to test you. Example. Now, most textbooks will just tell you examples of vectors are acceleration, velocity, etc. See, that etc is where the question is coming from. So that is, let's give enough example. Acceleration, velocity, displacement. I want to appreciate my wife in the building that also give me the opportunity to also do something like this. So very that she has been very helpful to make sure we progress. And also I want to thank my manager also that are doing very great work to make sure people learn and we are doing a good job. And if you are enjoying the video, please subscribe so that you can get more of our video. Now we have what? Momentum, torque. Impulse and momentum are the same thing. So in case you see impulse in an exam, they are writing the same thing. Then we have what? Electric field. All fields are vector. All fields are vector. Maybe electric field, magnetic field, gravitational field are vector. Then all forces are vector. All forces. Now all forces like what? Viscous force, frictional force, weight, reactional force, upthrust, etc. on what force. That can list for you to list enough for then amplitude and what? And extension are what? There are three things I've mentioned here. Displacement measured in length, amplitude and extension. They are the only length measuring what? Quantities that are scalar, that are measured in meter. Length equivalent quantity that are scalar, that are vector rather. Every other ones are what? Are scalar. For example, now we have what? Mass. So to remember, all these students focus on the what? Vectors. Then anyone that is not vector is scalar. So try to practice vectors. So because in the exam, the which of the following is not a vector quantity. They will now put all this in there. Then you check the vector. Anyone that is not part of this class is scalar. Then you can also put temperature gradient. There are confusing part of what? Temperature gradient is a vector. Now, they will put what? Temperature here is what? For this level, I can say stress is a what? Is a vector for now, but normally it's not totally a vector. So, but let's take it for examination purpose. Surface tension, and so forth and so on. Surface, but you know that young modulus, pressure is where people is a scalar. Pressure is scalar. Current All electrical quantities are scalar. Capacitance, inductance, reactance, impedance, 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 resistance, all potentials are scalar. All potentials are scalar. Are scalars. What? Scalars. All potentials, like what? Potential difference, electric potential, EMF, electromotive force, EMF, and so forth. All energy are scalars. All energies are scalar, like what? Work, electrical energy, kinetic energy, and so forth and so on. Then on like length, width, height, what? Breadth, altitude are all scalar. Apart from, I told you, there are what? Many of the distance. Apart from these three, 1, 2, 3, that are lengths equivalent quantity, others are what? Scalars. So, and so forth and so on. Then any shape measuring, any quantity that has to measure the body, the solid, or the dimension of a particular shape, like volume, area, and etc. So we can have a lot of them. You can have them that are what? Scalars. That are scalar. Frequency, decay constant. So these are examples that I keep mentioning them, that are what? Scalar quantities, that are not vector. So we have mentioned examples of what? Vectors and scalars. Vectors and scalars. Density, very important. Density is also part of it. Density, then all the relative density, velocity ratio, mechanical advantage, all what? Dimensionless quantity, most of dimensionless quantity are scalars. Then strain, and so on and so on. They are all scalar quantity. So please take note that if you check this one now, there's something here. You see now, work is here. Energy is here, but you see now, moment and torque are here. Look at it. Where are they? Moment and torque. But they have the same unit to measure in Newton meter, but one is vector. Speed is here, but what? Velocity is here. You see now, they are all measured in meter. So it is possible that you have people from same family, but they are not. One does not have the direction, one has direction. So that is just that. Now the next thing that we want to do, which is the last thing, or second to the last thing I want to talk about. If you have a triangle like this, for example, and they give us something like this, look at this. They give us something like this. This is what? X, Y, let's see, S, Z, Y. And we are asked to what? To find what? They said, in the diagram, X, Y, and Z are vectors. Which of the following options gives the correct relationship between these vectors? They are looking for the relationship between the vector based on the arrow. Now, the question I will ask you now is, that is where I'm going to go to. What? Resolution of vectors. So no. When two vectors are moving in the same direction, what do you do? When they are moving in opposite direction, what do you do? When they are at right angle, what do you do? So we will first of all remove what is on the board, and then so that now we want to resolve all these kind of possible conditions for vectors, because if you can understand this, you can able to comprehend better. Now what we want to do now is that let us consider different forces, two different forces that are moving in various directions. Now, let's assume that they are moving in the same direction here. How, if two vectors are moving in the same direction, what do you do? F1 and F2. It's simply just to add them together. Just since they are, according to vector theory, say when two vectors are moving in the same direction, just add them together, F1 plus F2. But note, this particular case one is where they can ask you, in what way can two vectors produce a maximum vectors? A, moving in opposite direction. B, at right angle. C, in the same direction. D, when they are moving at an angle to each other. The answer is when they are moving in what? The same direction. That is what I'm saying now, is that this resultant produce the highest resultant of two vectors, whether the same or different. For instance, if I give you 2 Newton, or let's say 3 Newton and 4 Newton, for example now, what is the resultant of these two? Is 7. But if they are moving in opposite direction, it will have been what? 4 minus 3, which is F2, which is, I'm assuming F2 is bigger than F1. That's why I give 4 to F2, give 3 to F1. So 4 minus 3 will give us 1. So can you compare 7 and 1? No. Now, if they are now at right angle, let's say we give, this one is 4, and here is 4, and here is 3. If you want to find the resultant, now the resultant will be 5 Newton. And you see that 5 Newton can never be compared with 7, although it's greater than 1. Then if you now take the parallelogram, maybe you now take the angle, let angle 60 be in between them. Let's say you now take 4 square, take 4 square, you take, take 3 square, because F1 is 3, take 4 square, you now take angle between them, let's say 60, 180 minus 60 is what? 120. Cos 120 is the same thing as what? Minus cos 60, which is what? Minus 0.5. So minus cos 60 is the same thing as what? Cos 120. Reason being that cos 120 is in second quadrant. If you check your this is a second quadrant. So since it's in second quadrant, cos 120 will be giving us negative, because in the second quadrant, cos is negative. So you are going to have cos 120 as it as cos 60, negative 60. But if it's cos sin 120, it will have been positive cos sin 60. So this one will be what? Minus 2 times 3 times 4 minus 0.5. At the end of the day, when you take square root of this one, it will be smaller than this. I don't need to compare it before you know. This one is 9 plus 16 plus, this one is 12, 24. 24 times this will give us 12. 12, this is what? 28. 28 plus what? Plus 9 will give us 37. Square root of 37 should be about 6 point something, which is not close to 7. So that is to say that if two vectors are given to you, that's it. In what direction can these two vectors move for them to produce the highest resultant when they are moving in the same direction? And when two vectors are moving in the same direction, what is the angle between them? 0. Please take note of that. What about opposite direction? 180. Because if one is going like this, the other one is going like this, angle on a straight line now is 180. So now, but if they are at right angle means what? 90 degree. If they are at right angle to each other, if you want to solve them, you use Pythagoras theorem to solve their resultant. Then when you use Pythagoras theorem to solve their resultant, this will be the direction. You take note of that. This is the direction of this resultant. This is the direction here. So how do you find the direction? Direction is tan inverse. Don't forget, here is opposite to this one, is opposite, and here is what? Adjacent. So if I want to find tan phi, what do you have? Tan phi equal to opposite is what? F2 over what? If you want to use Socatua. Then making phi the subject of formula, you have tan inverse. So now this one for parallelogram, maybe the angle between the two forces is 60, not 90 now. Or probably if it is 120, to look like, it will be like up to, this one is acute parallelogram. Now, if you want to solve this, you use parallelogram law, which is what we call to find the result and use cosine rule. No cosine rule now. Now, this place is the angle between them. This place, don't forget, this angle is the same thing as this angle. They are called corresponding angle. This one, because these two lines are parallel. So in maths, when you have two parallel lines and you draw a line, this angle, if here is 30, here will be what? 30. So this angle is equal to this angle. And how do you get this one? This one will not be what? This is angle on a straight line. So to get this one is just what? 180 minus this one. You get this one. That is what we did. Now, if you draw the diagram clearly, if you draw everything clearly, now what you are going to see is something like this. Now, you are seeing something like this. Here is what? 180 minus alpha. You can see it. Here is your R, which is your resultant. Here is your F2. And here is what? F1. If you want to use cosine rule, we have two sides and one included angle already, because it must be included angle now to find R. So that is why we use this one to solve it. Then you want to find, this is the direction. Please. The direction of a resultant is always inclined to the what? To the horizontal. This is the horizontal now. So that's why your direction, the direction of the resultant must always incline with the what? The horizontal axis. That's why I say this is the direction. So how do you get the direction? Now you can use what? What do you call it? Sine rule. Which side is facing this one? Is root F2. So that's the F2 over sine phi, which I did here. Then which side is facing this part, this angle? Because you know this angle is R. That's the R over sine what? 180 minus alpha. Very easy. So you get your answer. That's what I did to get direction. You use this formula. To get magnitude, you use what? Cosine. So those are the things. Then how do you resolve? I've already written this one for, so it not be rough. So now, how do we resolve? Now, anytime an angle is lying on, where is the angle? This angle is lying on this axis. That axis will take cos. Any side that the angle is lying on, when it says sleeping on, this angle is resting on this what? Horizontal axis. Therefore, this side will take cos. So if you resolve this one now, this one will be what? R cos theta 1. Then this place that has space, you know, this one is space, R sin theta 1. Then this one called, if you want to resolve, where is it lying on? Where is it resting on this particular resultant? On the vertical. That's why it take cos. Then if you check, this one is negative y. This is what? So that's why I put what? If you check, I put minus here. But for this one, I put what? Plus. So how many forces do you see on the vertical axis? 2, 1, 2. One is positive going up, then one is going negative down. How many do you see on the horizontal? 2 also. But they are going towards the what? Because this one is positive s-axis, and they are found in that side. So that's why the two of them are positive. So if you want to find it now, after you have resolved like this, the next thing to do is to add this one together. You get, well, probably you get P, for example. You add this one together, maybe you get Q. So it will form the next what? P squared plus what? P squared. That's how to find the resultant. This is the formula to find the resultant. Then if you want to find the direction, you now what? To find direction, that be what? Tan phi equal to, which one is on the y-axis? Which one is on the y-axis? F of y of this. Which one is on the y-axis? Q, abi? Which one is on the x-axis? P. So you just what? Take phi equal to tan inverse of what? Q over what? Over P. You get your answer for direction. So that is how to get direction of that. Because all this, if you sum it together, will give you P. Sum this one together will give you Q. This is your what? Component, Y component, total. Then when you do your P on summation P square, summation Fs square, then put Q in summation Fy square, Q square, take square root of everything. Then you get, then to find direction, because it will, when you now resolve all this now, it will now be in what? In kind of right angle triangle. So you now be in what? One will be what? on the Q side, which is what? Vertical. Then one will be on the horizontal. To find direction now be tan inverse, tan phi equal to Q over P. Then tan inverse of it will give you the answer. So that is everything about vector for now. So let's take question quickly so that let's rush the question. Now, this is one of the questions here. He said, how do we find result and use this method now? Don't forget, I say when two vector moving, he said that you add this application now. So how do you do that? Quickly. Let me clean this out. How do you do that? Now, which one and which one is going in the same direction? Question. Y and what? Look at it. And Z. So it's now be Y plus Z. Which one is going in opposite direction? X, Abi, is equal to X. So this is your answer. Except you now have it in different way. Maybe you can have a okay, you can say, do you know that you can write it as what? X, I can take this one to the other side, Abi. Minus Y minus Z equal to what? You can see write it as what? I can take this one here and say what? X, okay, Y, excellent, plus what? Z minus what? Equal to 0. So it now depends on how the answer will show up. So what I'm having here is what? I'm having X equals to Y plus Z, which option A is correct. Option A is correct there in my option. So option A is correct. So that is correct now. It's correct. So now let's take a question like this. This question is resolution. Let's take question on resolution. The question says, look at it. We have a diagram like this. And this diagram, we have what? Then there is an angle here. This angle is what? 60 degrees. We have here to be 4 Newton. Then here is what? 3 Newton. I say from the what? The diagram, two vectors with magnitude 3 Newton and 4 Newton act at the point. Calculate the magnitude of their resultant. The magnitude of their resultant. Look at it too. The magnitude of their resultant. How do we solve the magnitude of their resultant here? Now what we want to do now is simply what? Let's resolve. Now if we want to resolve this thing, don't forget that this one is lying on the what? Is this 4 Newton, the angle is resting on the what? Horizontal. So if I want to resolve it, I will now see what? There will now be 4 cos what? 60 degrees, Abi? Because when this other vertical side will have what? 4 what? 60 degrees. Now, that is the only thing we can resolve. This one is already on a particular, this particular 3 Newton has chosen a direction already, which is the negative X direction. Then this one is what? You say what? The direction is okay, is going this way. Abi? Okay, the direction is going this way. Sorry for that. It's going this way in the question. So that means if it's going this way, it's facing the what? Yes. And this one, if you resolve it now, look at the arrow. If you resolve, let's assume this the cover is the arrow. If you resolve it, what went in that direction also. So how many forces do we now have going that direction? We have 2 now. That means on the positive x-axis, because this one is pointing positive x-axis. So x component and y component. So what do we have now? We are on the x component. We would have what? 4 cos 60, Abi, and what? 3 Newton here, Abi. On the y component, what do you have? Only one, Abi, which is 4 sin 60. Only one going up, positive. Why we take this one as positive? Because this one is facing towards the what? Positive x-axis, Abi. So resolve. So if you resolve this one, cos 60 is what? 0.5 times 4 is 2. 2 plus 3 is what? 5. Then sin 60 is what? Root 3 over 2. So 4 times root 3 over 2 is what? 2 root 3. That's what I would have. So this one is 2 root what? 3. So if you do that now, because our answer is in short form, you understand me? You are not going to use calculator to solve problem here, because some professional exam, you don't use calculator. So this one now go R equal to what? R square equal to what? To this is our summation fx summation fy. I told you before now, the formula is still on the board there. Thank God. I've not cleared it. So this one now square root of what? 5 square plus what? 2 root what? 3 all square. So this one will give us 25 plus what? This one means 2 root 3 times 2 root 3. What do we have? 4 times 3 is 12. So what do we have now? Square root of what? 37. If no, that means we remove this one. So you have to remove that one, please. Because of what we have here. So this one is our resultant unity. So we have it in our option there. So that is option what? A. We have it in our option. So you have to be very careful to solve, and when you are solving, I think we are done with vector there. You can solve one more to solve one more question so that I will just leave this topic. We have tried to move to the next topic. This one said what? Two forces, 3 Newton and 4 Newton. 4 Newton act on a body. Act on the what? On a body. In what? In direction. In direction due north and what? And due east. This kind of bearing question I want us. Then that's respectively. See, calculate. If you have any vector question that you want us to also solve, you can also, send it to the comment section. Calculate their what? Their equilibrants. Equilibrant. I want to touch this one because I have not talked about equilibrant. Now, there is difference between equilibrant and resultant. Now, if I give you these two forces now, 10 Newton and 3 Newton, what is the resultant? The resultant is the summation of the two forces acting in the direction of the force. Is the summation of is algebraic sum of two or more vectors acting in what? In the same direction as the forces, having the same magnitude as those forces. That means that what I'm saying is that if I want to find the resultant now of these two forces, the resultant is 13 Newton. Why? Because they are moving in the same direction. Now, this 13 Newton is the resultant. Now, if you check the characteristic, the 13 Newton is equivalent to the sum or the algebraic sum of the two of them. Number one. That is, it's also acting in their direction. Two things is doing now. That means that the resultant is a what? The algebraic sum of two or more vectors having their what? Their magnitude and also acting in their what? That direction. But equilibrant is what? Opposite, which is the same magnitude but opposite. So if I give you now 4 Newton in the north direction, what will be the equivalent of 4 Newton in the north direction? That means 4 Newton in the what? South direction. That is it. It's as simple as that. That is what equilibrant does. So what I want to do now, I want to use this person to solve for equilibrant. Let's see what will happen. Let's see what will happen. It's a very interesting question. So after this one, we move. So he said what? Two forces, 3 Newton and 4 Newton act on a body in the direction. North is for 3 Newton. This is what? You have the north, east, south, and what? West. So where is north now? North is up, which is 3 Newton. Where is east? To move due means straight line through the north. Then due east is what? 4 Newton. Because they say respectively, meaning that accordingly, the way they are arranged. Now, what do we do? They say what? This is the resultant. Let me show you something here. This is the resultant. But this is the equilibrant. Look at the equilibrant here. I'll show you something here. This is the equilibrant of. This is the angle, direction. and this is the direction of this one here. So this is equilibrant, and this is the what? Resultant. This is the direction of the resultant, and the direction of the what? Equilibrant. See now, this one is opposite of this one. This one is opposite of what? This one. So, but would they have the same magnitude? Yes. If here is 10 Newton, here will be 10. I don't need to find this one. I can look for this one. So, but they have opposite what? Direction. So now, let's see. Let me solve for what? Resultant becomes what? Square root of what? S component is Y component is here. S component is here. What is Y component? The only force we have on the Y component is what? 3 square. What about S? 4 square. So if you find this one now, take your square root, you are going to have 5 Newton. It's 5 Newton you are going to have. Now we have gotten your resultant. So the equilibrant is also 5 Newton. The resultant is also 5 Newton. The problem of this question is not the magnitude, because all of the options here have the same 5 Newton here. Where they are waiting for you is the direction. Now, how do you find the direction now? Let us find this direction here and relate it to this one, the opposite one. Because the direction here, this one is saying north, theta degree what? East. But this one is saying what? West, theta degree what? South. So this one will now be what? Let's say tan theta, let me use theta. Tan theta equals to what? Opposite is what? 3/4. So this one will give us what? 0.75 equal to tan theta. Now, what I will do now to know my this value, like I say 0.75, give me x degree to know this theta. Then tan 45 is what? 1. Tan 45. 45 degree is equal to 1. You can cross multiply. You cross multiply, what do you have? S equals to what? 45 times what? Because tan 45 is 1. So anything I get here will be for this angle. Is 45 times this one. 0.75. So what we have now is 75 times what? 45. I'm going to have it as what? Divide by what? 100. So 75 times what? 45. Give me what? 45 carry 2. This 35 plus 20 will give us 55 plus 57. Then carry 5, 28 plus 5 is what? 33. So 33 divide by what? 100. That means 33 point what? Something. So if you check now, if you now check option, that means your value, because option will show you help you. The answer we are getting now is about, it should be within the range of 37 and thereabout. 36 point something. So that means what we have. So if here is what? If you press your calculator, it's not 36 point something. 36 point what? 87, I'm correct. So I'm going to have it 36.87, which is correct. So that means tan inverse of what? That is just a shortcut to remember. Tan inverse of 0.75 case of the exam case is what? 36.87 degree. Now, which is approximately what? 38. And the case may be 37, approximately 37 degree. Now, I haven't done that now. Look at what I want to do now. Now, here is now 37, abi? 37. What will be here, class? 37. But now, if you want to interpret it, how do you interpret? They're going to say what? 5 Newton, comma, west what? 37 point what? 37 degree what? South. Why did I take west first? Because it's resting on where? West. If I want to read this one, I would have read this one like east, 37 degree north. But do you know if this thing is, if I say here and look at this one. Is this one now be, let's say we balance it. 90 minus this one will give us what? 53. Abi? 53. Now 53, now this one now south. You can write that what? 5 Newton, comma, south what? What? West. Abi? Do you know you can write this one as what? 53 degree what? West of what? South. Abi? If you want to introduce off, you can take this one back. This one can also be what? Similarly, yes? What will 37 degree what? South of west. So that will be your equivalent, this side. So if you check the option now, we have option A, we have 5 Newton, 53 degree east of north. That one is trying to, okay, let's read the option. B says for 5 Newton what? 53 degree west of south. I think that one is there. We have that one there, Abi? West of south. So this one is the answer now. You see that they did not put this one in the option. They not put this one. So we have 4 possible answers now. That's where the vector problem is. So, or the direction. The problem is not from the way, the magnitude or whatever, is the direction. This one can be attached to this. I can attach this answer to this. It's also correct. I can attach this one to this. Correct. Attach this one to this. It's correct. The one we saw in the option is this to this. You understand me? So this will not be the answer. So I believe we are able to explain vector to understand. You want to know more? Go and check my vector video to get more calculations and analysis on vector. Thank you.